Children, today we will learn another measure of dispersion which is known as standard deviation. Right? Now, what is standard deviation? Standard deviation was introduced by Carl Pearson in 1893. Right? He was the economist, Carl Pearson, and he introduced this concept of standard deviation. And when did he introduced it? 1893. Now it is also called root mean square deviation. This is another name for standard deviation. In short, we call it standard deviation, but another name is root mean square deviation because under root is taken in this out of the square deviations. It is denoted by Greek letter sigma. So this is about standard deviation in brief. Now we will see the meaning of standard deviation. Standard deviation is the square root of the mean of the squares of deviations of items from their arithmetic mean. So here in this case, the deviations are always taken from arithmetic mean. So standard deviation is the square root of the mean of the squares of deviations of items from their arithmetic mean. This is the definition of square deviation, and we will learn the calculation and then it is more clear to you. The square of standard deviation is sometimes also called variance, right? Sometimes it is also known as variance, the square of standard deviation. Standard deviation is known as root mean square deviation and square of standard deviation is known as variance. Now let us see the calculation in case of individual series by direct method. You remember the direct method means when the deviations are taken from actual mean. In the case of indirect method, deviations are taken from assumed mean. So this is the direct method of calculating standard deviation. What are the steps? First, calculate mean value of all items of series. We have to take the mean value considering the items of the series, taking into consideration all the items of the series and taking out the actual mean value. So calculate mean value of all items of the series. Second, find out deviations from mean, that is dx is equal to x minus x bar. So here deviations are always taken from actual mean. It is labeled as dx, which is x minus x bar. Then third step, obtain sigma dx. When we got dx, then obtain total of dx and find out sigma dx square, right? Because it is square deviation, so find out sigma dx square. Next step, divide sigma dx square by number of items. Number of items, or you know, that is n, right? Now next step, find out square root of the mean of square deviations. Square deviations, what you have calculated, this one, find out the square root of the mean of square deviations. Now this is the formula. SD, this is sigma sign, as I told you there, it's a Greek letter sign. Sigma or SD is equal to sigma d square upon n, under root of sigma d square upon n, or it is equal to under root of sigma x minus x bar whole square upon n, or sigma dx square upon n, as I told you, dx square, or sigma x minus x bar whole square upon n, or sigma d square upon n. So this is the formula, any of these. dx square is a square of deviations. What deviations you have taken out is square of these deviations, that is known as dx square or d square, and n is the number of items. Now we will take the example to make it clear to you. Example here, individual series, the example is 3, 4, 6, 7, 10, 30, this is the x given to you. Now what you are supposed to do? First you have to take out mean and then take out the deviations from mean and then take out the square deviations, right? Take out the mean, take out the deviation from mean and then do the square of deviations. So x you will copy down like this. This is 10, sorry, this is not 30, 6, 3, 4, 6, 7, 10. This is given to you 3, 4, 6, 7, 10, and then you have to calculate x bar. Now sigma x, this is 10, 20 and 30. So this was written here as 30, right? The total sigma x is 30 and n is how many items? 1, 2, 3, 4, 5. So 30 upon 5 is equal to 6. So x bar is equal to 6. This is actual mean of the data given here. Standard deviation, as I told you, the formula is here, sigma d square upon n. When you have calculated mean, that is 6 over here, first you will take out the deviations, x minus x bar. 3 minus 6 is minus 3. Here you will not ignore minus signs. Minus signs we ignore only in case of mean deviation. In case of standard deviation, we will take into consideration all plus and minus signs. So x minus x bar is 6, 3 minus 6 is minus 3, 4 minus 6 is minus 2, 6 minus 6 is 0, 7 minus 6 is plus 1, 10 minus 6 is plus 4. Now next step is make a square of deviation column, that is d square or x minus x bar whole square. So you will make the square of these items. Minus 3 into minus 3 is 9, sorry, minus 3 into minus 3 is equal to 9, minus 2 into minus 2, the square of this is 4, 0, 1, 4 into 4 is 16. Do the total of this, and this is sigma d square is equal to 30, right? Now what does your formula say? SD is equal to sigma d square upon n whole under root. Sigma d square here is 30, write down 30 here, n is number of items, these are 5, so write down 5 here, make the under root sign, then it is 5, 30 divided by 5 is 6 under root, and under root of 6 is 2.45, and this is standard deviation. So always you have to take out the under root in the case of standard deviation. Coefficient of standard deviation is standard deviation upon mean. Standard deviation you have got 2.45, write down here, mean is 6, write down here, and this is your 0.40 is coefficient of standard deviation. Clear? So it's a very simple calculation. Whatever series are given here, copy down the x column, take out the mean, take out the deviation from mean, square the deviations and get the total, that is sigma d square, write down the formula, put the correct values and get the answer, right? So this is a direct method because we are calculating through proper arithmetic mean, right? In the indirect method we will take the assumed mean, not the arithmetic mean. So steps in the indirect method, let us see that. First take deviations of items from assumed mean. Here we took the items deviation from actual mean. Here the deviations of items are taken from assumed mean, that is x minus a, and denote it by d and obtain sigma d. So deviations will be named as d and the total of d column will be sigma d. Second, square deviations and obtain sigma d square, as we did here. Obtain sigma d square, apply the formula. Now in the case of assumed mean, you see there is a different formula, whereas in the case of direct mean or direct method, in the case of actual mean, the formula was very simple. So this is the formula for assumed mean. And remember children, this is the common mistake which is done by children. They are applying this method, taking out actual mean and applying this formula. Or sometimes children take the assumed mean and apply this formula. Then it will be totally wrong. Answer cannot be correct and the method itself is wrong. So remember that whenever you are taking the actual mean, formula is this. Whenever you are taking the assumed mean, this is in direct method assumed mean, and this is the formula for assumed mean, and this is the formula for actual mean, right? So don't get confused, keep this in mind. Now in the case of assumed mean, this is the formula what we are going to apply. Now same figures I have taken 3, 4, 6, 7 and 10. Copy down the figures, take out the deviation from assumed mean and do the square. Now how do the assumed mean calculated? You know the formula for assumed mean, x bar is equal to a plus sigma dx upon n. Now sigma dx, here we take assumed mean as 7, we have assumed as 7 as assumed mean. Now let us see, 3 minus 7 is minus 4, 4 minus 7 is minus 3, 6 minus 7 is minus 1, 7 and 10, 3. So assumed mean sigma dx is minus 5 and number of items are 5 and assumed mean is 7, right? Now the formula standard deviation is equal to, this is the formula, same formula written down here. Here I have not written dx, whether you write it or not this is understood. So dx square upon n minus sigma dx upon n whole square whole under root. Now sigma dx square is 35, so in place of this write down 35, n is 5 number of items, n is 5, then sigma dx is minus 5, so write down minus 5, n is 5 whole square. Then if we simplify it, 5 7s are 35, 7 and this will become 1, 7 minus 1 is equal to 6, under root of 6 is 2.45. So this is standard deviation. Simply the values are given here, take out the deviation from assumed mean, do the squares of these deviations and apply this correct formula, put the values after doing the total of these two columns, put the values and get the calculation done. Coefficient of standard deviation is standard deviation upon mean, because we are taking deviations from mean. So 2.45, in this case we have taken 7 as assumed mean, so it becomes 0.35. Here it was 0.40, now coefficient is 0.35, little different, because assumed mean we have taken as 7. Clear? So this is about direct method and indirect methods. Two methods you have learned of calculating standard deviation in the case of which type of series? These are individual series. No frequency is given. Now another method is step deviation method. if the figures are quite big, here I have taken only simple figures, but here if the figures are in thousands or lakhs or whatever, complicated figures are there, then sometimes the calculation becomes too heavy. So in that case, step deviation method is considered better. Then it makes it simpler. First, the steps are: take any value of x as assumed mean. From the x column, select any value as assumed mean. Find out deviations of x from a, that is x minus a, which will be dx. Take c, common factor from dx. Take the square of dx dash as dx dash square. Now as you have taken common factor from dx column, this is dx column, you take the common factor. So first you will multiply by the common factor, first you will divide by common factor, then later on you multiply it. Let us see when we will do the calculation. And this is the formula, same formula here what you have taken here in the case of assumed mean. Here also we are taking assumed mean, same formula is there, but the only difference is dx dash. You can see a stroke over here, dx dash. What is dx dash? That is, dx dash is dx divided by the common factor, that is dx dash. Now example, age 50, 70, 100, 150 and 130. This is x column given to you. So in the x column write down these figures, take the assumed mean. Here we have taken assumed mean as 100, so this is assumed mean, right? A plus sigma dx upon n, 100 plus 0.5, so x bar is 100. We have assumed 100 as assumed mean. Then a is 100, dx will be 50 minus 100 is minus 50, 70 minus 100, x minus a. So 70 minus 100 is 30, minus 30, 100 minus 100 is 0, 150 minus 100 is 50, 130 minus 30 minus 100 is 30. You will not ignore minus signs, you will take all the signs into consideration. Then dx dash is dx divided by c. C is the common factor. Here we have taken common factor as 10. These are round figures, so we have taken, because all these are divisible by 10. So common factor here is 10. 50, 70, 100 all can be divided by 10. So we take 10 as a common factor. So dx, this divided by a common factor c, that is 10. When we divide it, that becomes dx dash. So minus 50, when we divide it by 10, it becomes minus 5, minus 30 divided by 10, minus 3, 0, 50 divided by 10 is 5, 30 divided by 10 is 3. Now here it will become 0 because it is minus 5 minus 3 and plus 5 plus 3, it is 0. Squares of these 25, 9, 0, 25 and 9, and total of this is 68. So first you will copy down this, take the assumed mean, take out the deviation, here 100, take out the deviation of assumed mean, divided by common factor and make the squares, right? Now apply the formula, under root of sigma dx dash upon n minus sigma dx dash upon n whole square into c, because here we have divided it by c, so here we will multiply it by c to balance it, to equate the value. Now sigma dx dash upon n, sigma dx dash upon n. Now this is upon, this is square, this is 68 upon 5, n is number of items, dx dash square upon n is minus sigma dx dash is 0, dx dash is 0, 0 upon n, that is 5, and whole square into c. So 68, this value, n is 5, this value here, and n is 5, and c common factor, c is 10. Simplify it and we get standard deviation as 36.88. Right. So in the formula put the correct values and simplify it, take out the under root and get the answer. Coefficients of standard deviation upon mean. Standard deviation we have taken out as 36.88, mean is 100, you have taken it as 100. So this one coefficient is 0.36. This is the answer. Right. So standard deviation is also very simple. You have to follow particular steps and you have to apply the correct formula at correct place and put the correct values, right, in place of the formula, put the correct values with each item and get the correct answer. So I think it is interesting for you, and till now you have done one part of standard deviation, that is calculation of standard deviation in individual series. Next we will proceed to rest of the two series. Till then practice these sums, learn the method, learn the steps and enjoy working over the standard deviation. You have learned the calculation in case of individual series. Now next is discrete series, and these are the steps what you are supposed to follow while calculating standard deviation. There are three methods of calculating standard deviation. One is direct method, second is indirect method, and third is step deviation method. So there are three methods. So we will take one by one. First is direct method. These are the steps when you are calculating standard deviation by direct method in the case of discrete series. First, determine mean of the series. Direct method is the method in which you are taking out the deviations from actual mean, not the assumed mean but the actual mean. In case of indirect method, we take out the deviations from assumed mean. So in the direct method you have to take out deviation from actual mean. So first thing is determine mean of the series. Series means the given data. Whatever data is given to you, you have to take out the actual mean. You have to calculate actual mean and then calculate x minus x bar. That means x bar is the actual mean. Now deviations are taken out by following this method, x minus x bar is equal to d. These are the deviations from mean, and calculate dx square. So when you calculate d, then this is d or dx and then make a square of it and then it becomes dx square, right. Third is multiply with corresponding frequencies. This dx square you will multiply each figure with the corresponding frequency. Corresponding means whichever is given in front of it. So corresponding frequencies are used to multiply dx square and we get sigma f dx square, because we have multiplied dx square with frequency. So it will be f dx square. When you do the total of it, that will be sigma f dx square. After getting this, apply the formula. This is the sign for standard deviation. Standard deviation is equal to sigma f dx square upon n. N is the total number of frequency or sigma f. So this formula under root, because you are taking out the standard deviation, you have to find out the under root of sigma f dx square upon n, or standard deviation is equal to sigma f in bracket x minus x bar, because you know dx is x minus x bar. So, square of it, that is sigma dx square. Sigma f is here, another form dx you are explaining as x minus x bar. So, sigma f dx square upon n, that will give you standard deviation, right. Now, we will take an example. This is the data given to you, x and f. X column is 2, 4, 6, 8, 10. Frequency, that is f, is 1, 4, 6, 4, 1. Here frequency is given because this is the case of discrete series in which frequencies are always given. So, x is this much and f given as 1, 4, 6, 4, 1. Now, for solution, as you have to calculate these values, you will follow particular steps and make different columns. Accordingly, this x column and f column, this will be always first two columns, you will copy down the data. X as it is given to you, write down here. F column as it is given to you, write down here. Clear? Now, you have to find out actual mean. This is the first step, and for actual mean, you know the formula is x bar is equal to sigma fx upon n. So, this is clear that you have to calculate fx. X is given to you, f is given to you, multiply both the columns and you will get fx, do the total and divided by n. So, fx here is this multiplied by this, 2 into 1 is 2, 4 into 4 is 16, 6 into 6 is 36, 8 into 4 is 32, 10 into 1 is 10. This will give you fx and the total is 96, that is sigma fx. Now, after calculating mean or after getting these calculations done, find out the mean. X bar is sigma fx upon sigma f. Here sigma fx is 96, f sigma f or n is 16. So, x bar is equal to 6. 96 divided by 16 is equal to 6. This is your mean x bar. Now, next step is you have to take out the deviations. Deviations are x minus x bar. X bar you have calculated, that is 6. X is this, x minus x bar, that will be 2 minus 6, that is minus 4, 4 minus 6, x minus 6, 4 minus 6 is minus 2, 6 minus 6 is 0, 8 minus 6 will be 2, 10 minus 6 will be 4. So, you will calculate dx column, that is x minus x bar. Now, next step is calculate dx square. This is clear, dx is this and dx square will be square of each item. 4 into 4 is 16 and is minus will become plus, minus 4 into minus 4 is plus 16. Then minus 2 into minus 2 is plus 4, 0, 2 into 2 is 4 and 4 into 4 is 16. So, you are making square of these and you get these figures. Now, next step is your formula says sigma f dx square. Dx square you have done. Now, you need f dx square. How will you get it? Dx square, this column and f. Multiply these two columns, then you get f dx square. Because dx square is already given here and f is here, multiply these two columns to get f dx square. And 1 into 16 is 16, 4 into 4 is 16, 6 into 0 is 0, 4 into 4 is 16. This is 16. 4 into 4 is 16 and 1 into 16 is 16 and the total is 64. Right? Now when you have got the total of these columns, now apply the formula. Formula is SD is equal to sigma FDX square upon N. N is the same as I told you, N or sigma F. So this is the formula. Sigma FDX square is 64, write down 64 here. N is 16, write down 16 here. Divided, you get 4 under root of 4 is 2, and this is your standard deviation, right. So first you have to calculate the values, put the right formula and do the calculation, right. Then coefficient of standard deviation is standard deviation upon mean. Standard deviation is 2, mean was 6, 2 upon 6, and this will be your coefficient of standard deviation. I think it is clear to you. So this way, in the case of discrete series, if we apply the direct method, we have to apply this formula, that is the same one, and get the values and do the calculation. Answer will never be wrong. Okay. So this is one of the method you have done. Now next is indirect method. Indirect method is the method in which deviations are taken out of assumed mean, right. So indirect method, size and frequency, this is the data given to you. Now let us see how do we do the calculation. Now here solution, you have to make first size and frequency, x column, this is size column, frequency you will note down in the same order here, first two columns. Then you have to assume certain value from x column as mean. Here in the central value is either 4 or 5. So I have taken 5 over here. This is assume mean. We are assuming 5 as mean. 1 minus 5, d is equal to x minus a, and a is 5. So 1 minus 5, x minus a is 1 minus 5 minus 4, 2 minus 5 minus 3, 3 minus 5 minus 2, 4 minus 5 is minus 1. Then 5 minus 5 is 0, 6 minus 5 1, 7 minus 5 is 2, 8 minus 5 is 3. Clear? Now next is do the square of d column, because the formula here, this is the formula for standard deviation. So you need d square, fd and fd square according to your formula. So make the square of d column, that will give you d square. Minus 4 into minus 4 is 16, minus 3 into minus 3 is 9, minus 2 into minus 2 is 4, minus 1 into minus 1 is 1, 0, 1, 2 into 2 4, 3 into 2 3 is 9, right. Next step is find out FD, because you need FD here in the formula. So you have to find out FD. How will you find out FD? This is D column and this is F column, right. Then you will multiply these two columns, that will become FD, right. 5 minus 4 will multiply these two figures, you get minus 20, 10 into minus 3 is minus 30, 15 into minus 2 is minus 30, 20 into minus 1 is minus 20, 15 into 0 is 0, 10 into 1 is 10, then 10 into 2 is 20, 15 into 3 is 45, and do the total of it, because your formula says sigma FD. So this is the total of this, add up minus signs together, add up plus signs together, take out the values, and then it is minus 25, right. Now next is, here it says sigma fd square. So you need fd square. Now here for fd square, don't do the square of fd, right? Keep this in mind. This is a common mistake done by children. Fd square is not the square of this. If you take the square of this, that means you are making square of frequency also. But here it is fd square, that means frequency into d square. That will give you fd square, because square is here not over f, right? So frequency, this is the frequency column f, and d square is this. Now this time you will multiply f with d square and you get fd square. 5 into 16 is 80, 10 into 9 is 90, 15 into 4 is 60, 20 into 1 is 20, 15 into 0 is 0, 10 into 10 is 100, then 20 to 10 is 400, sorry, this is 15 into 0 is 0, 10 into 1 is 10, 10 into 4 is 40, you are multiplying this column, not this one. 10 into 1 is 10, 10 into 4 is 40, 15 into 9 is 135. And if you do the total of this, this is 435. This is sigma fd square. Now after getting these three values, because these three values are needed over here, so you have calculated the total of these three columns. Then write down the formula. Standard deviation is equal to under root sigma fd square upon n minus sigma fd upon n whole square. Now sigma fd square is 435, write down 435, this is n, either n or sigma f, n is 100, write down 100, sigma fd is minus 25, write down minus 25, n is 100, write down 100 whole square, simplify it, and this you will get as standard deviation, right? Now coefficient SD upon mean 2.07, this is SD, mean is A, that is 5, and multiply it, and this is, you divide 2.07 upon 5, you will divide this figure by 5 and you get 0.41 as mean, right? So this way, in the indirect method we apply this different formula, and don't mix up with the formulas. Direct method has got different formula, indirect method has different formula. If you are taking deviations from assumed mean, always write down this formula. If you are taking deviations from actual mean, write down this formula. So this way two methods you have done, and we are left with the third one. This is known as step deviation method. As I have told you earlier also, step deviation method is very suitable when the figures are very large, because if the figures are big, you need large calculations and there may be chances of errors also. In that case, we divide the values with certain common factor or class interval, and then in the end we multiply the value with the same class interval, so that calculation becomes easier. So let us see what are the steps here. Step deviation method. First is take any value as assumed mean and denote it as A. It is normally done with the assumed mean. So here denote it as A, assumed mean. Find out mid values of class interval. Now if the class interval is given to you, then you find out the mid values. If the class interval is not given to you, now here in this case class interval is not given, so we will take out this value only, whatever is given here, because this is the case of discrete series. In the case of continuous series, you have to calculate the mid values. So, in the case of discrete series, whatever x values are given, take deviations from A, name it as D. Take out deviations from A of the x column, x minus A, and that will be D. Divide deviations by common factor, that is D upon I, and when you divide D by I, then it becomes D dash. So, divided by common factor, common class interval. Multiply D dash with corresponding frequency and find out sigma f D dash. D dash will be multiplied by corresponding frequency, and when you do the total of that column, then you get sigma f D dash. Find out sigma f D dash square as you have done here in the previous example. Then apply formula. This is the formula, the same formula as you have taken here in the case of indirect method. The only difference is that you can see there is a stroke here, that is D dash, because you have divided it by class interval, and in the end multiply it by same value, class interval. Now, x and f, x is this one here. As I told you, this is not the case of class interval. If the class interval is given, you have to take out the mid values and then this will become x. But here this is the case of discrete series. Write down the x column here, f column, copy down first two columns. Then you have to take any value as assume mean from the x column. The central value is somewhere here. So, this will be assume mean. A is 35, 5 minus 35 is minus 30, 15 minus 35 is minus 20, 25 minus 35 is minus 10, 35 minus 35 is 0, 45 minus 35 is 10, 55 minus 35 is 20, 65 minus 35 is 30. So, x minus a you will calculate and name it as D. Take out deviations from assume mean. Now, next step is find out D dash, that is D column divided by class interval. Now, here the class interval, that is 10, right, 5 to 15, interval is 10. So, if you take 10 as class interval here, then minus 30 divided by 10 is minus 3, minus 20 divided by 10 is minus 2, minus 10 divided by 10 is minus 1, 0, 10 divided by 10 is 1, 20 divided by 10 is 2, 30 divided by 10 is 3. So, you will divide D column with the class interval what you have taken here. Then D dash square, make the square of this column, that this square of this column will become D dash square. So, minus 3 into minus 3 is 9, minus 2 into minus 2 is 4, minus 1 into minus 1 is 1, 0, 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9. Clear? Now, you need FD dash and FD dash square as your formula says. So, FD dash you will multiply F column with D dash column, multiply these two columns, 10 into minus 3 is minus 30, 15 into minus 2 is minus 30, 25 minus 1 is minus 25, 25 into 0 is 0, 10 into 1 is 10, 10 into 2 is 20, 5 into 3 is 15. So, by multiplying f d dash we get f d dash. Do the total of it because you need the total here. This is minus 40. Then last column f d dash square, as I told you, do not make the square of this, f d dash square. Now, this time these two columns will give you f d dash square. So let us see how do we get it. 10 into 9 is 90, 15 into 4 60, 25 into 1 25, 25 into 0 0, 10 into 1 10, 10 into 4 40, 5 into 9 is 45, right. Now again do the total of this, you get 270. So you need to do the total of F column, FD dash column, FD dash square column. These values are needed in the formula. So you, if you know the formula accordingly, you know that which column you have to make, which calculations you are supposed to do, and which column total you have to do, because you know the formula and you know where to put the values, right. Now let us see, standard deviation is equal to sigma FD dash square upon n minus sigma FD dash upon n whole square into class interval. Now FD dash square, this is 270, write down 270 here, n is 100, write down 100 here, minus sigma FD dash is minus 40 and n is 100 whole square into I is 10. Simplify the values and you will get the standard deviation as 15.94, right. So very simple, learn the formula, accordingly make the columns, put the values, and simple calculation is done and the answer is here. Now coefficient of standard deviation, very simple, standard deviation upon x bar 15.94 upon, here 35 we have taken as mean, this is 0.45, this is coefficient. So in this way, this calculation of discrete series, you have learned in three type of series, calculation of discrete series you have learned by three methods: direct method, indirect method and step deviation method. Now this is your choice, which method you find more suitable for which type of data, and accordingly you can select any of the method out of these three to do the calculation of standard deviation in discrete series. But children, always keep this in mind that whichever method you are applying, use the correct formula, right, and follow the correct steps by applying the relevant or correct formula and do the simple calculation and you will get the correct answer. Okay, so enjoy working. Okay, I think you will get the correct answers and there won't be any problem. As you have done in the case of individual and discrete series, the calculation of continuous series, that is also a simpler calculation. The only difference is that in the continuous series, you know, the class interval is given 0 to 10, 10 to 20 and so on, and you have to take out the mid values of the class interval, right, and then the whole series will be converted in the form of discrete series, and then you can do the calculation in the same manner as you learnt in the case of discrete series, right. So let us see with the example. Now continuous series, now this is the direct method. As I told you earlier, three methods are there: direct method, indirect method and step deviation method, and we will take each one. Now in the direct method, first step is find out mid values of various classes, right. So class interval is given and you have to calculate the mid value, and you know how to calculate the mid value, L1 minus L2 upon 2, right. So mid value you have to calculate, and then second step is calculate x minus a, that is dx. A is the assumed mean. Now in this case A is assumed mean, or you will take out sigma fx upon n, this is actual mean, right. So when you are taking direct method, then you will take out the actual mean, arithmetic mean. When you are taking indirect method, then you take the assumed mean. Now here third step is multiply frequency of each class with deviations and get sigma fdx. Now when you take out the deviation, x minus, here you can write down x minus x bar, because this is the direct method, and assumed mean will not consider in this case, and so x minus x bar is equal to dx or sigma fx upon n. This is through actual arithmetic mean. Multiply frequency of each class with deviations, whatever deviations you have got, that is dx. Multiply these deviations with frequency and do the total to get sigma f dx. What is dx? Dx is this x minus x bar multiplied with frequency, it becomes f dx. When you do the total of this, then you get sigma f dx. Next step, find out sigma f dx square. You have to make the square of f dx column. Why? Because standard deviation is sigma f dx square upon sigma f. So when you have calculated sigma f dx, make a square of it so that you can put the value here. Next is apply formula. Standard deviation is equal to sigma f dx square upon sigma f, right. So you have to put the values here, sigma f dx square upon sigma f. Now for example here class and frequency is given. Class is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. This is the case of continuous series, so we have taken the class interval here. Frequency 10, 3, 2, 1, 4. This is the series given to you, this is the data given to you, and on the basis of this data you are supposed to calculate standard deviation and coefficient of standard deviation. Now here let us see the solution. First you will write down the class as given, then next step, in front of class you calculate x. What is this x? This is the mid value. So 0 to 10 mid value is 5, 10 to 20 mid value is 15, 20 to 30 mid value is 25, 30 to 40 mid value is 35, 40 to 50 mid value is 45. So after the x column you will make the frequency column. Frequency you will copy down in the same order 10, 3, 2, 1, 4. So respective frequencies with the class interval. Then you have to calculate fx column. Why do we need fx column? Because we have to calculate arithmetic mean. So fx column, this will be f into x, right. F into x is fx, 10 into 5 is 50, 3 into 15 is 45, 25 into 2 is 50, 35 into 1 is 35, 45 into 4 is 180. Now you do the total of these two columns. Frequency total is sigma f is 20 and fx column sigma fx is, add up all these figures and you get 360. Now first thing you will calculate the mean here. X bar is equal to sigma fx upon n, you know the formula for arithmetic mean. X bar is equal to sigma fx upon n. What is sigma fx? This is 360, write down 360 here. N is number of item or total of frequency, that is 20. So x bar is equal to 18. So this you have calculated as actual mean, and after calculating actual mean you have to take out the deviations from actual mean. Dx is equal to x minus 18. x is this column given to you minus mean, 18 is the mean, so x minus 18, that will be dx. These are the deviations. Here x is 5, so 5 minus 18 is minus 13, 15 minus 18 is minus 3, 25 minus 18 is 7, 35 minus 18 is 17, 45 minus 18 is 27, right. So, this way you have got dx. Now, your formula says dx square. So, you have to make the square of dx. This will be dx square. How do we make the square of this column? Minus 13 into minus 13, this will become plus 169. To make the square, you will multiply the figure with the same figure. So, minus 13 into minus 13, 169, minus 3 into minus 3 is plus 9, 7 into 7 is 49, 17 into 17 is 289, 27 into 27 is 729. This way you have got dx square, but still your work is not complete because you need f dx square, right. How do we get f dx square? Multiply dx column with frequency. Dx square into f will give you f dx square. So, multiply this column with frequency. 169 into 10, 1690, 9 into 3 is 27, 49 into 2 is 98, 289 into 1 is 289, 729 into 4 is 2916. So, this way you get the value for f dx square, right. Multiply each item with the corresponding frequency. After this, you need sigma f dx square, so you have to add up this to get the total sigma, you know that is the total. So, sigma f dx square is add up all these columns and you get the figure 5020, right. Now, one part of this is complete, you have made the columns, you have got the concerned values or the values what you need in the formula that you have calculated over here. Now, next step is apply the formula, and as I told you earlier also, first you write down the formula always, because without writing down the formula you cannot put the values and you will lose marks if you do not write the formula. So, first we will write down the formula. This is the sign for standard deviation. Standard deviation is equal to sigma f dx square upon sigma f whole under root. This is the same formula as I have given you here, right. Sigma f dx square upon sigma f whole under root. You write down the values and take out the under root of it. So, same formula. Now, sigma f dx square, this we have calculated here, this is 5020, so write down here 5020 upon sigma f is 20, write down 20 here, make the sign of under root. After this, when you simplify it, it is under root of 251, and if you simplify this figure 251, you get this as standard deviation 15.84, right. Now, after getting the standard deviation, you are going to calculate coefficient of standard deviation, and you know how, you have done it earlier also. Coefficient of standard deviation is what? This is equal to standard deviation upon x bar, right. Now, standard deviation is 15.84, so write down 15.84 here, x bar is 18, so write down 18 here, divide it, and this is your coefficient of standard deviation. Clear? So this is the direct method of calculating standard deviation in case of which type of series? This is the case of continuous series. Okay. Now next we have indirect method, and as you know, indirect method always have assume mean. Mean is, or you can say deviation is taken out from assume mean, not the direct mean. And in case figures are big, you know that here the figures were quite big, but not as big as it is difficult to calculate. But if figures are quite big, fx needs long calculation, then in that case normally we take the assume mean. Okay, let us see here the same example I have taken over here. This is the class given as it was given here, same example. Class, take out the mid values, this is x column, mid value of 0 to 10, 5, 10 to 20, 15 and so on. Then frequency you copy down in the same order, 10, 3, 2, 1, 4. Now you have to assume mean from which column? Will you assume mean from this column? No, you have to assume mean from x column, not even this one, because here there are two figures, you cannot assume mean out of this. So where you will assume mean? You will assume mean from x column, and here suppose we take assume mean, any value we can take, but here we have taken the central value 25. So x minus a, that is 25. A is the, this is a, this is assume mean, right. So we assume the mean here. Now we will take out the deviation to find out dx. How do we find out dx? X minus a, or x minus 25. Now take individual series or take each item here. First 5 minus 25 is minus 20, 15 minus 25 is minus 10, 25 minus 35 is plus 10, 25 minus 45, sorry 35 minus 25 is plus 10, 45 minus 25 is 20. Now do the total of f column, because this is the formula what you are going to apply in the case of assume mean, right. So you need n or sigma f, do the total of this column. Now after getting these values you have to calculate f dx, because you need f dx over here. This is f dx square and this is f dx. So you have to calculate f dx, then dx square to get f dx square, right. Dx square you have to calculate to get f dx square. So here after calculating dx column, multiply it with frequency, this and this, multiply these two columns and you get the values. For example, minus 20 into 10 is 200, that is minus because here it is minus 20. Same way minus 30, you multiply these two columns and get the values. Do the total of this column, because you need sigma f dx. So do the total, it is 140 here. Now next is calculate dx square, that means make the square of dx column, that is dx square. Minus 20 into minus 20, 400, minus 10 into minus 10 is 100, then 0, 10 into 10 is 100, 20 into 20 is 400. This way you have got dx square. After getting dx square, in order to get f dx square, what you have to do? Multiply dx with f. If you multiply dx square with f, you get f dx square. See what we have done over here, 400 into 10, 4000, 100 into 3, 300, 0 into 2, 0, 100 into 1, 100, 400 into 4, 1600, right. So this way you have calculated f dx square, and after getting this you have to make the total of this sigma f dx square, and the value here is 6000, total of this column. Now after doing this calculation, first write down the formula, apply the values, this is the formula. Now sigma f dx square, this is 6000, so you will write down 6000 here. N is sigma f, that is 20, write down 20, minus sigma f dx is 140, write down 140, this is minus 140, so write down minus 140 upon 20, that is sigma f, and this is whole square. Then simplify the values, you get 251 under root, always under root sign here, do not forget to write down under root sign, because standard deviation is the under root of certain value. So under root of 251 you have got, simplify this and you get 15.84 as standard deviation, same as you got it here. In the previous example, because we have taken the simple we have taken the same example, so 15.84 and 15.84 is the answer, right. Coefficient of standard deviation 15.84 upon 18, this is SD upon x bar. Now here we have taken 25 as assumed mean, but coefficient is taken out from the actual mean. So we will take the, either we calculate the actual mean here, or as we have taken the same example, we know that actual mean was 18. So 18 we have taken here, 18 is the actual mean. If you are taking another example, then you have to calculate the actual mean to take out the coefficient. So 15.84 upon 18, 18 is the actual mean, and the answer is 0.88, same answer, right. So this is indirect method, or doing calculation by taking out the assumed mean or taking out the deviations through the assumed mean. Now third method is step deviation method. This is the third method in which deviations are divided by class interval and the value in the end is multiplied by class interval. Now same example as I have given earlier, class interval same, this is the mid value, this is the frequency, right, this is the total of frequency column. Now in this case A is 25 central value, assume mean, this is the deviation 5 minus 25 minus 20, same way. Now the next column, this is another column which was not earlier, this is extra, that is D dash, D dash is D divided by class interval. Here class interval is 10, right, 10 to 20, interval is 10. So class interval is 10 in this case, divide D column with 10, minus 20 divided by 10 is minus 2, minus 10 divided by 10 is minus 1, 0, 10 divided by 10 is 1, 20 divided by 10 is 2. So divide D column by the class interval and take the class interval as given in the series. Now after dividing it you have got D dash. Next is, because this is the formula sigma f d dash you need, so D dash will be multiplied with frequency, multiply this column with D dash column, then you will get f d dash, this is f d dash, multiply both the columns and you get the values here. Then you have to make the D dash square, right. Why do we need D dash square? Because we have to calculate f d dash square. For that you have to make the square of D dash. How do we make this column? This is D dash, make a square of this column, minus 2 into minus 2 4, minus 1 into minus 1 is 1, 0, 1 into 1 is 1, 2 into 2 is 4. So, make a square of d dash column and you get d dash square, right. Then multiply frequency with not this column now, this column. Then you get what? F into d dash square will give you f d dash square. Multiply these two columns, 10 into 4 is 40, 3 into 1 is 3, 2 into 0 is 0, 1 into 1 is 1, 4 into 4 is 16, right. After doing this, do the total of sigma f d dash. Why? Because you need it here, right. Do the total of this column also, though we do not need it directly, but we need sigma f d dash. Do the total of this column and you get 60 here. Now put the values after writing down the formula first. This formula is sigma f d dash square upon n minus sigma f d dash square f d dash upon n whole square into I. I is the class interval. Now sigma f d dash square, let us put the values. In this place you get 60, so write down 60 here. N is 20 minus sigma f d dash, how much? Sigma f d dash is 14, write down 14 here. N is again 20, write down 20 here, whole square into I. This will become 3, 60 divided by 20 is 3 minus whole square of 14 about 20 is 0.49. I is the class interval, that is 10, and then simplify it, you get same answer 15.84, right. This is your standard deviation. And again, in order to find out coefficient of standard deviation, SD upon x bar we have already taken as 18 by calculating actual mean. So 15.84 upon 18 and same answer 0.88, right. So in this way you have learned all the three methods of calculating standard deviation in the case of continuous series, and in each case you have learned that it is very easy to do the calculation provided you know the steps well and provided you know the formula properly. Then it becomes very easy to calculate, and it is very interesting also because you keep on moving with the flow, because you know the formula and you know which column you need. Accordingly you make the column and just flow with the numbers and you will get the answer, right. So this way you have learned the calculation of standard deviation. The whole calculation of standard deviation must be clear to you now by all different methods in different type of series. After learning this, it is very important to know the merits and demerits. This we cannot ignore. So after doing all the calculation, let us move to merits and demerits of standard deviation, right. First merit, uses all observations in the set of series as the deviation is taken out from mean. So we can say that first merit is that it uses all the observations in the series by taking out mean, right. It is not like quartile, or you can say it is not like range, which is not taking all the observations in consideration. So in this way all the observations are taken into consideration. So this is a good measure. An ideal process when deviations are calculated from arithmetic mean. When deviations are taken from arithmetic mean, it is considered a very ideal process because it is very accurate, right. In the case of assumed mean also, it gives a correct figure but maybe slight variation, but if the deviations are taken from arithmetic mean, then total answer is very accurate, So this is considered to be a very good measure of dispersion, well defined and definite measure of dispersion, as it is very clear, it is well defined, it is systematically calculated, so it is considered as well defined and definite measure of dispersion. A comprehensive measure of dispersion and can be used in all situations, as it is a comprehensive measure of dispersion, right. It is taking all the aspects into consideration, it is covering all the values of the series, so it is useful in case of all type of situations. Situations here means all type of data. Now demerits, little difficult to calculate. It is little difficult to calculate in the sense that you need to make many columns and the formula is little difficult, but I must say that it is not exactly difficult, but little you can say elaborate in comparison to other measures of dispersion, and you have to take out the under root also, which some of you may find little difficult, but you have to learn that also. So in this way, in certain cases if the figures are large and you have to calculate the under root and you have to make large columns, then in that case you will find that it is little difficult to calculate because it is a long process. But if you learn the method properly, if you know the formula properly, it is not that difficult also. So one demerit is little difficult to calculate, right. Gives great importance to extreme values. This is second demerit. It gives great importance to extreme values. How can you say that? This is because you are taking out deviations from mean. Though it is very accurate to calculate deviations from mean, but you know when mean is taken out, then sometimes the average or mean is affected by extreme values. If the values are ranging from 1 to 1 lakh, then the mean may be on the higher side. If more values are on the higher side, mean will become higher. So sometimes it is giving great importance to extreme values, right. This is in case of mean. If the values are extreme, they are quite you can say different from each other or quite away from each other, then in that case this is a demerit. Third, not easily understood by a common man. By a common man, this standard deviation is not very easily understood, but for people like you who have learned statistics, who have developed interest in statistics and who know the steps very well, then you can understand it very easily. You are not a common person. So in this case it is difficult for a common man who does not have knowledge of statistics, right. But if you have a knowledge of statistics, you know what is statistics, you know the methods and steps what are to be followed, then it won't be a difficult measure of dispersion, right. Fourth, cannot be used for comparing dispersion of two or more series. Now here we are taking the example of one series only, one type of data is given, one series is given, then you have calculated standard deviation. Now if two and more than two series are given, then in that case this method is not proper. For that we have another measure of dispersion, what you will be learning next, that will be Lorentz curve, right. That gives the dispersion of two and more than two series by making a graph, which you will be learning in the next lecture. So in this case I say that this method cannot be used for comparing dispersion of two or more series, but for one type of series this is a very good method, right. So this way you have completed the knowledge about standard deviation, your calculation is complete, merits and demerits are over, and we will move to the next part, that is Lorentz curve, another measure of dispersion. Till then, bye bye.